Hello and welcome to my home studio. Normally I make these videos at school, but we're doing remote learning, so I'm here at home in my little home studio. This week, when you're with me at school, we'll be getting you ready for your ecology test, and then the 2 days you're at home, you'll be doing these weather units and lessons at home on your own. So we'll go through the notes. I know you can just read them, but sometimes it helps if someone explains it with you or for you. It's Some of this topic is quite complicated. It's getting to a lot of grade 11, grade 12 chemistry, but we'll just introduce it. And like I said, we'll keep it pretty straightforward when it comes time for your exam. Okay, so heat transfers. What makes the earth warm? Well, that sounds like a simple question, but it's not a very simple answer. We've talked about weather, this whole idea of weather. Weather is just what happens to the sun's radiation after it hits the earth. It can get quite complicated, as we've already seen. So today our first definition is something called thermal energy. So thermal energy, the energy of motion of particles that make up a substance. That sounds pretty straightforward. If you take grade 11 chemistry, we'll talk about that in more detail. That's actually getting into something called the kinetic molecular theory, about how particles collide and how they move. But for now, just if you realize the energy of motion of particles is called thermal energy, and heat is simply just thermal energy. It's not quite that simple. I've got this book. A former student of mine got me this book when she graduated. It's called Zapped. Each chapter is about a different type of radiation. So to understand heat thoroughly, you'd have to read this whole book, which I have. But for now, we'll just say heat is thermal energy, and we'll leave it at that. Okay, so the next slide, we're talking about radiation. So the radiation that comes in from the Earth is not the same that the radiation that leaves the Earth. So we talked about that. And again, radiation, you'd have to read this whole book to understand. Oops, I've got it backwards. Read this whole book to understand radiation. In grade 12 chemistry, we have a whole unit about the different types of radiation. So for grade 10 science, all we need to know is that the radiation that comes in from the sun is shortwave radiation. And the energy that leaves from the Earth is longer wave radiation called IR infrared. That's all we need to understand. So the wavelength of the energy coming in from the sun is shorter than the wavelength of the energy leaving. Greenhouse gases. We've talked about them quite a bit. We've talked about them already in our ecology unit. You'll talk about them in future years and future courses. Now, when we talk about greenhouse gases, we tend to talk about how they're bad, but they're not actually all bad. We do have some that naturally exist, and we do need greenhouse gases there. Last lesson, I showed you that video of that person on the moon. The problem with the moon is when all the energy that comes in pretty much leaves. So it's really, really hot during the day, really cold at nighttime. So the reason why the Earth has this ideal atmosphere for us is because of these greenhouse gases. We need to trap some of these greenhouse gases here and hold it. Otherwise, it would be way too cold at night. So you need to keep some of these greenhouse gases trapped in our atmosphere. That's a good thing. The problem is with human interference and other things, we are trapping too much and we're getting too much of a buildup. We're actually changing our climate and changing the overall global temperature. So that's the issue. But we do need some. It was in perfect balance before we kind of interfered with it. So the greenhouse gases act as something called a heat sink. We talked about heat sinks last lesson. They trap heat in the troposphere. That's the layer of the atmosphere where we live, and that's where weather occurs. So that's why we had that first lesson about the atmosphere and learned about the different layers. Okay, so now that we know what thermal energy is, how can it be transferred? So there's 3 ways you can transfer thermal energy: radiation, conduction, convection. I love this diagram. You're going to see it on every slide for the rest of this lesson because it basically visually explains everything. So it comes in as radiation, then something called conduction happens, and then convection. So we'll go through these 3. So radiation is just absorbing of energy of a heat source. So basically the solar energy coming in, that's radiation. And the fun fact here is that it doesn't need a medium. It can travel even through the vacuum. The other 2 processes, conduction and convection, they need a medium to transfer in. But no, radiation, just basically the solar energy coming in, hitting the Earth, that is radiation. Now, what happens to that radiation that hits the Earth? Well, it depends on what it's hit, right? It could hit water or it could hit land. Then you have something called conduction. Conduction is the transfer of thermal energy between 2 substances. So that's where you need the 2 substances, the medium, that are in physical contact. So conduction is just energy transferred by direct contact. That's the simple definition. I think you did study this in previous years. I can't remember if it's grade 6, 7, or 8 science, but you should have talked about conduction and convection previously. So conduction just moves from substance with higher temperature to lower temperature. So that's why when you touch, don't do this for science sake, if you touch the handle of a pot that's hot, the hot temperature will transfer from the hot pan to your hand. That's conduction, direct contact from high to low. So land and water will absorb that solar energy. So the radiation that came in, the water, the land, they will absorb it. And then when they absorb it, the molecules in the ground and the water collide more often. We're getting to that grade 11 chemistry, kinetic molecular theory. So higher temperature will be more collisions of the particles. And then with the air that are close to the surface, and that transfers energy from the ground to the air above it. So that is all conduction. Then our third and final step is something called convection. That's a transfer of thermal energy by the movement of heated material from one place to another. So here's a simple definition here. Convection is energy transferred by the mass motion of molecules. So conduction is what makes the air above the land and the water warm. So step one, radiation came in from the sun. Step two, conduction. You have the transfer from high to low temperature. And then when the water and the land warm up, then they will warm the air above it. Hot air rises, cool air falls. So warm air is less dense, so it expands and rises. The higher, colder air is less dense, so it will fall and replace it. So that's convection. Hot air rising, cold air falling. And that's it. Those three thermal transfers of thermal energy is what produces all the weather we have. Okay, so if we were in class, I would be showing you those videos. Even though you're at home, I do encourage you to click on the links and to look at these videos because they do help explain the concepts a little bit more. So your assignment today is all from the textbook, page 284, number 5 and 6, page 289, questions 5, 9, 10, 11, 12, 13. I know this is getting into some higher level science and concepts, but we'll keep it pretty straightforward, and your textbook questions are doing a good job of that. And our funny joke of the day, a day without radiation is a day without sunshine. Haha, it's a cool, cloudy, rainy day now, but we know the sun is still there. Okay, good luck with your assignment. Bye.